Okay, so this is a mini lesson for EE1 and EE2. We're going to review exponent rules. You might want to write that at the top of this page. This is coming from your workbook, and this is the standard 8.EE.1 that we're going to cover first. So let's look at this first problem. We're going to write an equivalent expression, and notice that each one of these bases are 6. Every one of them are 6. And also notice that they each have an exponent, 3, 2, 5. And we don't see one on this last 6, but it would be 6 to an invisible 1. So we are multiplying like bases. When we multiply like bases, just a reminder of this rule, keep the base and add the exponents. And the reason we do this is because multiplication is just repeated addition. So we're going to keep our base 6 and add the exponents. 3 plus 2 plus 5 plus 1, and it's going to equal 11. Number 5, we are just going to simplify this expression, and I'm going to rewrite it with a fraction line for division. We have 2 to the 4th power divided by 2 to the 10th power. This means the same thing, because remember, a fraction line just means divide. And so we're going to think about our exponent rules. We've got 2 to the 4th power divided by 2 to the 10th power. So we have a rule that says to divide like bases, keep the base and subtract the exponents. It's just repeated division. So we're going to keep our base 2. We're going to take our exponents 4 and subtract the denominator 10. And so 2 to the 4th minus 10th power would be 2 to the negative 6th power. So I could write it as that, or I've also got a negative exponent, and so I have a little rule that says write a negative exponent as a positive in the denominator under 1. So that's just quickly summarizing my own words, but it's going to cross the fraction line and become 2 to the positive 6th power. And so it's simplified in that form. If you had a negative exponent in the denominator, you can cross the fraction line and move it to the numerator, and it would also become a positive exponent there. You just got to cross the fraction line. Okay, number 17, we're going to select all pairs of expressions that are equivalent, that equal the same value. So I'm going to start with this expression, 6 to the 7th power divided by 6 to the negative 2nd power. And so that's 6 divided, so we're going to subtract our exponents, 7 minus negative 2. And so when we subtract a negative, that's the same as adding a positive, and we get 9. And so 6 to the 9th power compared to 6 to the 5th power here, are they equal? No, they're not equivalent. So this one does not work. Then our next problem, we have 6 to the 3rd power raised to the 0 power. So we are raising a power to a power. Let's add this little rule as a reminder. To raise a power to a power, keep the base and multiply the exponents. raising a power to a power is repeated multiplication. So I'm going to multiply these exponents. 6 to the 3 times 0 is just 6 to the 0 power. Now I have another rule to remind myself of. Any base raised to the 0 power is 1. In other words, anything raised to the 0 power is 1. So 6 to the 0 power is just 1. 6 to the first power is just 6. Is 1 equal to 6? No. Our next one, 5 to the negative first power times 5 to the negative first power, that would be 5 to the base, and we're going to multiply like bases, so we keep the base and add the exponents. So negative 1 plus negative 1 would be 5 to the negative second power. Well, 5 to the negative second power is 1 over 5 squared, which is 1 over 25. Let's check this value here, 25 to the negative first power. That would be 1 over 25 to the first power, which is just 1 over 25. So these two are the same, so these are equivalent. Next, we have 8 to the 0 power times 8 to the third power. So we're going to keep the base 8 and add our exponents. 0 plus 3, we get 8 to the third power. And that is equal to 8 to the third power, so we can check that box. For our last ones, we have 4 to the negative third power divided by 4 squared. So we're dividing like bases, so we keep the base and subtract the exponents. Negative 3 minus 2, that's 4 to the negative fifth power. And that is not going to be the same as 4 to the positive fifth power. Those are not equal. Okay, standard 8.EE.1-2 is just calculations using square and cube roots. They could be found in little word problems. They could be found in little equations. We're going to start with this problem number 2. The area of a square is 36 square centimeters. What is the side length, S? And so it'd be helpful to remember the formula for area of a square. The area of a square is equal to length times width, which in both cases are the same side. So we can just say side times side, which is S squared. And here's what we know. We know that the area is 36. And so we're just going to solve for S. To get S by itself, we're going to take the square root of both sides. And we get S on the right side. And on the left side, we get 6. It could technically be positive or a negative 6, but we're dealing with a distance, so it can only be positive when we're dealing with distance, and it is 6 centimeters. Number 4, we're just solving this equation, x squared equal 49. So to get x by itself, we are simply going to take the square root of both sides. On the left side, we get x. On the right side, you might think we get 7, but we need to think of any scenario where we can take a value of x and square it to get 49. So it could be positive, and it could also be negative. So we get x equal positive or negative 7. And here is why. If I were to plug them both in to x squared equal 49, if I plug in 7 and square it, that equals 49. If I plug in negative 7 and square it, that also equals 49. So we get positive or negative 49. Positive or negative 7. Number 14, solve the equation x cubed equals 0.027. So all we're doing is trying to get x by itself. So we have x cubed is equal to 0.027, and we want to get x by itself by undoing the cube. So we can take the cube root of both sides. On the left side, the cube root of x cubed is just x. On the right side, the cube root of 0.027, you can go to your calculator, comes out to 0.3. You might wonder why we might not use the plus or minus sign like on answer choice B. And it's because if we had negative 0.3 equal x, which is false, by the way, then it would say that negative 0.3 cubed is equal to 0.027. But when you say a negative times a negative times a negative, it still comes out to a negative. So you'd get negative 0.027 equal positive 0.027, and that's a false statement. So that doesn't work.